Hi everyone, I'm Dipali Chandel and today's tutorial is regarding natural language processing with Python. So basically what is natural language processing? To understand that, first of all, what is natural language? Natural language is the language in which we humans communicate with each other. Okay. Now what is natural language processing? Natural language processing is a way to pre-process the data so that computer can understand that data. Or in other words, we can say it is the process which helps computer to communicate with us in our own language. Okay, so I hope the definition of NLP is clear to you. Fine. Now let's start with a library of NLP, that is NLTK. This is the very beginner library of NLP, and that is NLTK. So it stands for Natural Language Toolkit. Fine. Now this library was developed by Stephen Bird and Edward Loper. So it has so many built-in modules for tokenization, lemmatization, stemming and parsing, chunking and POS tagging. These are some process that we do to pre-process the data in NLP. Okay, it contains over 50 corpora and lexical resources. So basically what is corpora and what are lexical resources? Corpora is the collection of corpuses and corpuses is the collection of text data. Okay, and lexical resources is kind of a dictionary which contain information about words like synonyms, antonyms and other details about that like definition, okay, and some other details. Fine. Now to install NLTK we have to write this command !pip install NLTK. Okay, when you will run this, then your NLTK will be installed, and after installing you have to import that NLTK and you have to download the complete data from the NLTK, all the libraries that are there or the modules that are there in the NLTK using the download function. Okay, fine. So let's do that. Now, so I have already downloaded all those steps from here. So you can click on this download button and it is of around 3 GB. So it will take time to download. So I have already in my laptop. So I will not gonna do, I will not gonna click on this download button over here. Fine. Now, so first process over here is tokenizing of paragraph or sentences. So what is basically the tokenization? It is the process of breaking the whole text into the small tokens. Okay. It can be done on the basis of sentence and word. So there are two types of tokenization process. That first is sentence tokenization and next one is word tokenization. Fine. Now, to do that, first we have to import the sentence tokenized class from the NLTK library and word tokenized class from the NLTK library. So you can see these commands over here. Okay. Now, what is sentence tokenizing? So over here, the text, okay, text gonna break down into the sentences. That complete text. Suppose we have passed a paragraph inside this sentence tokenized function. Okay. Now it's gonna break that paragraph into the sentences. Fine. So let's see one example over here. I'm opening a file with the name natural language processing.txt with the help of open function. Now I'm reading it. Then you can see this variable contain my content of that file. Okay. Now I'm with the help of sentence tokenized function, I'm doing the tokenization process over that variable, over the content of that file natural language processing, which was stored in the txt variable. Fine. Now after the tokenization, that you can see that will be stored in the sentences variable. Okay. Now see, you can see the length of the sentences, it is showing 2. That means there are 2 sentences or 2 elements in this sentences variable. Okay, and we are printing it over here. So first element is this one, this is string, and the second element is this one. Fine. So this was sentence tokenization process. Now what is word tokenization? So in this what will happen, this word tokenized function gonna break the text in word by word. We can say words will get separated. Okay, so let's see how we're gonna do that. Simple. You have to call the word tokenize function and you have to pass the variable which contain the content. Okay, which contain the text that you gonna break word by word. Okay, now this text variable over here contain my text from the NL natural language processing.txt file. Okay, now I'm gonna break this. So with the word tokenize function, so those complete list of words gonna stored in the words variable. Then what is the length of that words? You can see it is 52. Fine, and I'm printing that variable words. So first word is this one, then second word is this one. So we are getting this in the list format. Okay, so now next topic is regex in this. So what is regex? Regular expressions are also known as regex, and it is very powerful tool for the programming. Why this is powerful? Because it is used for many purposes like feature extraction from the text, string replacement, and many other strings manipulations. Okay, now basically regular expressions are a set of characters or patterns which may be used to find substrings in a given string. Okay, for example, extracting all hashtags from the tweet, getting all the email IDs or phone numbers from a large unstructured text content. Okay, now for a few example about how does regex look like, regular expressions look like. So you can see over here in the square bracket A to Z, A hyphen Z. What does this mean? This means matches an uppercase letter. So we have to over there this regular expression gonna find that string which will match an uppercase letter. Okay, from A to Z. Now small a to small z, so it's gonna find that string which matches a lowercase letter. Similarly 0 to 9, okay, which matches a single digit from 0 to 9. Fine. Now coming over here, the next example, this symbol that you can see before capital A, so this indicate not. Okay, so it's gonna find this regular expression gonna find uh, that part of the string where uh, where we don't want an uppercase letter. Okay, where we don't have any uppercase letter. Okay, and over here you can see not capital S, small s, so neither capital S nor small s in this string. Okay, and over here you can see not period, that means not a period. Fine, so this is how regular expressions look like. Now to import that module, regex module, you have to write this command, import re. Fine. Okay, now coming to this part, punctuation. Okay, so punctuation, see basically in the text we have so many symbols, commas, and unwanted stuff. Okay, for analyzing a particular text, you should have a clean words. Okay, now to do that we have to remove the punctuation marks as well. So for that, what we can do, we can use the regex. Now I am just reading my this and natural language processing.txt file. Okay, and then you can see this was the content in that file. Now over here I am using this regular expression with the help of sub function. Okay, with the help of some sub function over here. So what it is gonna do, it gonna replace everything except all the letters which are in the capital and in the small, from capital A to capital Z and small a to small z. That means it's gonna replace everything except capital A to capital Z letters and small a to small z letters with the space. For which text? For this variable which contains this complete text. Okay, now let's see the output for it. So you can see over here we are getting this apostrophe 123 apostrophe at the rate then hash hash. Now you can't see over here that, okay, apostrophe is removed, then this 123 apostrophe at the rate is also removed and hash hash is also removed. Fine. Now coming to the stop words. So basically what are stop words? See, there are a set of words which does not add much meaning to a sentence. okay, and they are repeated more and more. So we should remove those words, okay, and those words are known as stop words, okay. To remove those words is very important to analyze the data. So basically there are 179 stop words in English. Now let's see. To look at the stop words, you have to import this stop words module from the NLTK.corpus. Now, from this module, I am writing this words function. That means I want words, stop words for English language. Okay, and over here we can have several languages. Okay, like Spanish and French and anything. So over here I'm writing English. So it's gonna give me stop words which are there in for the English language. Okay, so this is the list of stop words which are there in the English language. Fine. I, me, my, myself. Okay, now we have to remove this. So how are we gonna remove it? Again, over here we're gonna apply first of all this regular expression to remove the punctuation. Okay, now after that we have removed this punctuation above. The same text we are using, this one. Okay, and by this code we have removed the punctuation as well. So you can see after removal of the punctuation, this is your text. Fine. Now I'm creating an empty list. Now I'm applying a for loop over here. So w in filtered text dot split. So what it gonna do? First of all, it's gonna analyze all the words which is in the filtered text. That means first this will be, you know, w, then next w will be s, then next w will become language. Okay, because we are writing a split function over here. Okay, so by default if you're writing split, then it will gonna split with the space. Okay, now if w is not in stop words, then you can append your list which is clean words list. Okay, so if that w, okay, this natural, first value of the w is natural, so this natural does not belong to the stop words. Okay, so this natural will get added in the this list, clean words list, okay, with the help of append function. Now similarly it's gonna iterate over all the words over here. Okay, and then this clean words will contain all the words from this filtered text. Fine, without, if any stop words come in, like it is a stop word, so it will not it will not get added up in this list. Okay, so this condition will become false in that case, so this process will not take place. Okay, fine. Similar process will happen for R as well. This R is also a stop word, so this will also not come into the list clean words. Okay, now you can see the output for the list clean word, which is this one. So R is not there. Okay, it is not there. You can see R and it are removed. Fine. Now what is the length of this complete clean words? 28. Fine. So we can see how many how many words got removed. So let's see the length of filtered text as well over here. So it was 291. Okay, okay, and over here the length of the clean words is just 28. Fine. Okay, now part of speech tagging, that is POS tagging as well. So like we have in the English language part of speech, you know, like noun, pronoun, okay, adverb, adjective. Similarly the same process is there in the NLP as well. It is the process of converting a sentence to the list of tuples where each tuple will contain word and a tag beside that. Okay, and what will be the tag? Whether that word is adjective, whether that word is adverb, whether that word is conjunction or preposition or anything else. Okay, now we have so basically there are 8 main POS part of speech tagging. noun, pronouns, adjective, verbs, adverbs, preposition, and conjunction. So examples of them are these. Noun, like you can see names, okay, names of place, name of people, uh, or okay, basically what is whatever the noun is. Then verb, action words, okay, go, speak, run. Adjective, which indicate the quality or the numbers, okay. Then adverb, preposition, conjunction, pronoun, and interjection. Fine. Now, further we have in the further we have categories in those. Like conjunction, we have coordinating conjunction. Then we have cardinal digits. So after that we have determiner. Then we have extensional there, okay, which is the only word there over here, okay. Foreign words like dolls, which are not there in the language English, okay. Now preposition, subordinating conjunction. So we can read them further. Okay. Now coming over here, how to do the POS tagging. So first of all, what I'm passing a list in this function. Okay, NLTK dot POS tag. In this function, I'm passing a list which contain studying and study two words, two strings. Okay. Now uh, this post tag will gonna tag the part of speech for it. Okay. Now studying is a VBG, that is a verb, I think present participle, yeah, present participle something, and this study is a noun. Okay, fine. Now coming over here, so this is a sentence. Okay, this is a sentence. Now we want to tokenize, we want to do word tokenization over this sentence over here. Now for words, we did that part. After that, for words in tokenized words, that means we're going to analyze. Let's see what is the output for the tokenized words. Okay, now output of the tokenized words is this one. That means word tokenization took place. The sentence got break into the words. Now after that, for words in tokenized words, so we're gonna analyze for this for loop will run for, first of all, the words will be a, then words will become very, then it will become beautiful. Now NLTK.post tag function, we are writing this function which gonna apply the tags for all the words. Okay, so a is a determiner that you can see. It is returning us a list. This post tag function of the NLTK module returning us a list which contain tuples. Okay, for each word over there. So a is a determiner, very is a adverb, beautiful is a adjective. This JJ stands for adjective, this is for adverb, and this DT stands for determiner. NN stands for noun. Like this we can get, for each word the part of speech tagging. Okay. Now let's do that at a bigger level. So over here you can see this is a complete code. Fine. Now we are doing the first sentence tokenization because this is a paragraph kind of. Okay. Now after sentence tokenization, we're gonna pass this tokenize in the for loop. So for I in tokenize. Okay. Now NLTK.word tokenize I. Okay. That means first value of I will be 0. That means first sentence. Then I will become second. I will become 1. That is second sentence. So it's gonna do word tokenization for each sentence. Okay, for each sentence. So let's see. First print tokenized. Okay, so we got, this is my first sentence, I guess. Yeah. Okay, and this is our second sentence. Fine. Okay, now see. Okay. Now for I in tokenize, that means one by one all the sentences gonna be accessed. So first this sentence gonna exist, then this sentence. Okay. Now word tokenization will happen for first sentence now. So over here, W for W in word list, if not W in SW. What is SW? SW is, you can see, it is set of stop words. Okay, so that means in word list all those words will get added up which are not there in the stop words for first sentence. Okay, now we will do tagging for the first sentence now. Okay, and then after that what will happen, I will become 1. First I is 0, then I will become 1. So second sentence will come in. So similar process will happen. We do the tagging for the words of the second sentence as well. And then we are printing the tagged, variable tagged, okay, which is giving us, see, this is my tags for the first words of first sentence, and these are the tags for the words of the second sentence. Okay.